Okay, so this is Unit 2, Learning Target 1, calculate the rate of change from a graph. So what I want you to first do on your note sheet is jot down your definition in your words of a linear relationship. Whatever you can remember, any terms, if you want to bullet it, I don't care, whatever you can remember about linear relationships. So just pause and do that real fast. Okay, so now let's do our class definition of this. Our class definition is going to be a relationship that you can represent with a straight line graph characterized by a constant rate of change. So we all know what a straight line graph looks like, and it's moving up by a constant rate of change. And what we mean by that is if I have a value in my x that moves, my y is also going to move. Doesn't mean they have to move the same, but they're both going to move together. Your book uses the term recursive routine. We don't really like that term, but we still like the problems, and we just don't want you to get confused by their terminology. So like the book will call it a starting value. So like you start at maybe 5. And then they have like a rule, and their rule would be like add 2. So then their pattern is you start at 5, 5 and you add 2 is 7, 7 and you add 2 is 9, 9 and you add 2 is 11. So that's what they would use it as. We're going to use this as rate of change and our y-intercept. And so let's start with our rate of change. Rate of change is our m, our slope, our rise over run. These are all interchangeable. You'll hear rate of change, slope, m, rise over run. We're talking about the same thing. And the way that we find this is by doing our change in y, which we can represent as our change in y, and we do it as a fraction over our change in x. So again, like what I was saying up here is if y moves up by 1 and x moves up by 2, every time y moves up by 1, x is going to move up by 2. So they're both moving in relation to each other, but possibly not the same amount. And then our last thing is our starting value. Our starting value is our y-intercept. It's what we initially have. It's the y value is where our x is 0, so it would be this coordinate point of 0 comma something, and that something would be our value that we're talking about. That's our y value. So this would be our coordinate point for our y-intercept. On a graph, it's where the line crosses the y-axis, so it would be right here. On a table, we have a table of x values, y values. Here's our x is 0 value. Whatever this value is would be our y-intercept, our starting value. It's the same thing. It's our coordinate point. This would be 0 comma whatever this is, just like our coordinate point here. So we like to call that the y-intercept. So what they call their starting value is our y-intercept. What they call their pattern or what they're adding is going to be our rate of change. Okay, so let's look at this example. You walk into an elevator in the basement of a building. Its control panel displays 0 for every floor number. As you go up, the numbers increase one by one on the display, and the elevator rises 13 feet for each floor. The graph shows the floor numbers and their heights above ground level. So the first thing I want to do is I want to look at this graph. So I can see that my y-intercept, my starting value, is where my dot, where I would cross this line, and that's this point right here. So that's my y-intercept, and I can see that if this x is our ground level, I'm below ground level. And then when I move up to the first floor, I move above ground level, and it says I'm going to be moving. This tells me 13 feet, but even so, I can look. This is maybe like I started maybe at -4, so 4 feet below ground, and then once I move up to the first floor, maybe it looks like I'm up like around 9 feet. And so I keep moving up 13 feet as I keep coming up on each floor. So what is the rate of change for this situation? So remember, this is our change in y over our change in x. So my y's, how am I moving up by y's? I'm moving up 13, and it even tells me right here, I'm moving up 13. I'm changing 13 every time. I'm going up an additional 13. My change in x, how am I moving over? I start at 0, I go to 1. 1 to 2, 2 to 3. So I'm moving up 1. So my rate of change is 13 over 1, or you can just write that as 13. What is the real world meaning of this rate of change? Well, what is this telling me? It tells me that for every floor, so that means, so for every time I go up a floor from 1 to 2, from 2 to 3, from 3 to 4, we rise 13 feet. How is the rate of change represented in the graph? So in the graph, you can see that we're going up 13 and over 1. So we're going up 13 over 1, right? It's our slope. So we can see that we go up 13 over 1 every time. So before class, I want you to consider the following graph right here that shows the student's distance from her next class. So here's the distance over here, here's the time, and I want you to answer A, B, and C before class tomorrow.